Okay, so hello everyone. My name is Andrey Kovalev. Today I have two topics. One about the secure development lifecycle of our big product called Yandex Browser. It's more concept talk, more about the process. And my second talk is about the security, static security application testing. It will be second. It's more technical than concept. So I will try to speak a little bit slower. Sorry for my bad English, actually. Okay. So let's go. The first talk, how to implement a secure development lifecycle and don't turn gray. The first couple words about me. I am also a principal security engineer at Yandex. I am the postgraduate student of Bauman Moscow University, Bauman Moscow State University, Information Security Department. Now I am working at my PhD there. Also have some courses there. I am ex-malware analyst, actually, so I worked at Kaspersky Lab before, and also I worked at Yandex browsing team. It's like the small malware research laboratory at Yandex, which try to find out some dangerous stuff in the internet. For example, phishing web resources, drive-by download websites, sites with malicious files, and some stuff like that. After it, all these resources go to the safe browsing database. It's like the malware database. You know, maybe the Chromium. The Chromium browser has the same. The Yandex browser has also the same database, the same protocol, safe browsing API, but the different data sources. So we have our own database with our own system, which mines it. Yeah, and actually I'm the security researcher, have some publications with Evgeny, also have some CVEs, so that's it. Let's go to our topic. What it covers. First of all, I'm going to tell a little about the SDL itself. I also will highlight Yandex approach, which we performed for our Yandex browser. It's not canonical SDL, it's our own concept. I also cover some SAST security application, static security application testing, and dynamic security application testings drawbacks, and I will explain our solutions for that. And at the end of the talk, there is a summary. So let's go to the SDL 101. As far as you maybe know, the SDL was invented in Microsoft, and it was published in 2012, but they say that it used it in Microsoft since 2004. So it's the approach for, it's approach about performing security controls in all stages of program or product lifecycle. You can see that the Microsoft offers several security controls. The first one is the trainings. It's about working with your developers. It's about explaining them how to fix issues, why the issues are dangerous, and stuff like some stuff like that. The second stage is about the requirements. It's about the threat modeling, security measures, and some stuff like that. Also, the design is important. Implementation, verification, release, and response. I will not cover all these stages because you can just read and study about all approach. It's a complex approach, and the Microsoft has documents about with descriptions of such process. So you can just you can just understand that this is the process about performing security controls and all stages of program lifecycle, from design to release. There are several security controls which you can perform. But actually it's difficult, because if your product is developed using agile paradigm, you will have bottleneck performing all these steps, because it's a complicated and time-consuming issues. For these issues, Microsoft also gave answer. They released some materials about performing SDL in agile life cycles. So they divide all controls into in several groups. There are one-time controls, which you have to perform only one time. There are also controls. There are also controls that you have to do periodically. It's the bucket and sprint controls. These types are the different and they are influenced from your life cycle and your stages. So it's the flexible approach. For example, Microsoft says that everything is flexible. You can do some common security controls like threat modeling, fast testing, static analysis, and security review. And you can do it when it's convenient to you. So you can just use the flexible approach, use it when you need it. Not all stages are strict. But actually, very flexible approach is also could be not very good, because you can you could just have a bugs and not find them if you don't perform all the controls. So at Yandex we have our own approach for security development lifecycle, and it based actually on our development lifecycle. For browser, we have fixed lifecycle. Every release lives for 6 weeks, and we have several stages during the development. For security, there are two main stages. One of them called feature freeze. This stage is when we get the list of features which will go to release. So we just create the set of features, and we know that they will be released. After it, the security team connects to the process. The second main stage is the code freeze. The code freeze is the stage when all features which are going to be released are written, and we can just test them. It doesn't mean that there will be no bug fixes or any changes, but the code freeze means that the main code is frozen. So by default, there are no changes will be no changes will be performed. Sometimes exceptions happened actually, and we have to change some code after code freeze. But the main stage is that we just create a new branch. We move all code to this new branch, and there are no changes will happen to this branch. So for security, the feature freeze and the code freeze are the most important stages, because they have to security team have to work closely with command of the browser at these stages. Yeah, actually, for start the discussion, we have to provide some information to you about our development paradigm. So for Yandex Browser, we have Scrum-based Agile. We have sprints. Sprints last 2 weeks. We have also store points, and we measure all features with store points. One store point is actually approximately one work day. And we have several task types in our development process. There are product feature, technology task, and infrastructure task. So if you see our tracker, you will find only these types of tasks. The product feature is the product is the feature which is available for user. So, for example, if user can interact with some functionality, for example, he see the button, or he see the dialog, or he sees some warning message, or anything, it's the product feature. The product feature is the functionality which user could interact. The technology task, it's the task about, for example, improvement, the performance, or maybe some technical solution which works under the hood. So user actually doesn't interact with it, with it, and sometimes if we need to change something under the hood of our browser, we perform technology task. And we also have some infrastructure for Yandex Browser. For example, we have our own browsing API, as I mentioned before. We have infrastructure for browser updates. We have infrastructure for deliver our own configurations. And when we need to change something in our infrastructure, we create infrastructure tasks. So that's it. We also have several roles in our team. There are product manager, project manager, and developer. So the product manager thinks about the features and actually product features. He knows the markets. He knows how users work with browsers and some stuff like that. Project manager is about the development planning. He knows. He likes Scrum Master, he knows about store points, he knows about development team, he plans his development process. And developer is the guy who creates the code. Sorry. Several details. We also have one repository for Yandex Browser. It's about 10 gigabytes. We have several programming languages, C++, JavaScript, and Objective-C for mobile. Our code base is about 20% from Chromium, differs from Chromium, and we use TeamCity. So our CI system is TeamCity. Okay. After that, let's go to our main topic, our SDL approach. So we have only 5 stages in our SDL approach. The first one is the education. We also work with our developers a lot. We created some guides about the secure development. We highlight the most typical bugs in our guides. We spend a lot of time to explain about the bug fixing, because sometimes a lot of developers know about the bugs, but they don't know how to fix them correctly. We have the guide set with this information, and when the new developer comes to his first workday, he receives a letter from the security team with a link for these guides. And also in this letter, he can find the link to the special test. We use, for example, the Moodle system, the Moodle open source PHP system for creating tests. It's very easy to create tests for developers, for example, with multiple choice answers or even with open answers. So we use it for creating the test for developers. And after reading our guides, we think that the developer should pass our test. if he passes our test, he gets the special achievement in our internal social network called Staff. So, but we have not only guides. We also have the CTF. One year we performed a special competition for developers with actual tasks, and we also have the trainings. But trainings we have only for developers which are weak. We analyze our statistics from tests, and we also analyze our statistics from bugs, and if we find some weak developers, we also perform some additional trainings for them. So we work with developers a lot because it's very important. It's one of the main stages of the SDL process. Yeah, the second stage is the security design review. The security design review, it's about the architecture analysis, but we perform it not for release. For example, we perform it for feature. So we have the feature-based design analysis. I will cover it later. And we also have some automatization, and we have implementation analysis steps, and we use some automatization things for it. It's not feature-based, it's just release-based. So every release passes our security tests in CI system. Yeah, and at the end of our cycle, we have final security review. If some big features are released, it shall pass our additional hand security review. And after it, the release, we have response stage and we have bug bounty for our browser. Everyone could send us the vulnerability report, and we will provide the bounty for it. Okay, the main scope for our SDL is the security features. So we could not cover for this process all browser because it's difficult, but they cover several main parts. For example, all security features should pass the full cycle. Also, the new and complicated features also should pass the full cycle. But if we have just, for example, web API enhancement or some features that are potentially influenced for security, it could just, for example, pass the automatization steps. So let's go to examples, drawbacks, and solutions to explain our approach for you more easily. The first one is security design review. It's about the product security analysis, the product requirements analysis, and analysis of architecture. At the stage of feature freeze, we perform this action. We do it a different ways. Sometimes it's a meeting, sometimes it's just chat with the manager or developers in Telegram, for example, or in hours. So it should be done, but it should be done very convenient for developers. At this time, the feature is already designed from the development side. We have just to study if there are any issues there, and we use, if we find some issues, we have a chat with developers and explain them what they do wrong. So it should be done before the full code is written and before the code freezes. But actually, there is a concept usually for this stage, so we can just have a look at the concept, and also we can see some issues. At this stage, we also do threat modeling. We have two types of threat models. One, the general for the product, and one feature-based. For example, the general threat model is the typical threat model. It looks like this. It's the standard, the security vulnerabilities for browsers. You could just find it in Google Chrome VPR, or you can just find the same table at our website of our bug bounty. So it's the general basic security model for browsers. It covers the most important issues and vulnerabilities for browser. But not only this security model we have. Sometimes our developers create new cool features. For example, we have our own password manager inside the Yandex browser. And for this feature, we have different security model. For example, there are several attacks for password managers. For example, malicious site could steal the password from another site. Yeah, it's it's the usual issue, but actually there are several issues also. For example, when the user forget to lock his computer and go to get some coffee, the bad man could get to his computer and to steal passwords also. So for this feature, we created additional, the special feature-based security model, which includes all these steps. For example, the local attack surface, the remote attack surface, and some stuff like that. We create this this threat modeling in our design analysis stage, and we explain to product managers, to developers, our point of view, and explain the attack surface. The next step is the static analysis. Static analysis we perform for release. Actually, we have several copies of our CI system of TeamCity and perform static analysis for night builds, for beta builds, and for release builds. But our responsibility is to check, the first is to check the beta and release for release builds for vulnerabilities. Why do we need SAST, actually? Because, for example, the Google Chromium usually speaks about the dynamic analysis and never speaks about the static analysis. Actually, we have the platform-specific code for Windows. A lot of our users are Windows users, and we have to analyze that code. Nowadays, you couldn't perform good dynamic testing for Windows. There are lack of the powerful fuzzers, there are lack of the sanitizers. Yes, there is WinFL, for example. Yeah, the solution maybe. Have you ever heard about WinFL? Maybe. Oh, okay. So at Windows, there are several solutions. They use the RDB.io framework for instrumentation, but it doesn't work fine, actually. So for performance analysis, we have to use the static testing. Also, static testing could provide you high code coverage. You don't have to write special fast tests, or you don't have to even have the unit tests, which are required for dynamic testing. You could just set up your CI system, set up the static analysis tool, and run the analysis. It's more easier than performing dynamic analysis. And you also don't have to have the huge testing infrastructure like ClusterFuzz, maybe. Yeah. But there are drawbacks, of course. The main drawbacks is that there are lots of false positives. If you could see, the signal nose is horrible. If you just set up some SAST solutions and without any tuning and run it on your product, you will find that only about 20% of vulnerabilities are correct, and 80% vulnerabilities are false positive, unfortunately. Yes, and actually for C++ language, for example, there are also additional issues. If you know the Chromium code base and Chromium code style approach, you know that they were like shared pointers and unique pointers semantic. They use it every time they could. The complicated semantics are not clear for static analysis tools, so all static analysis tools, in our own opinion, are failed analyzing this code. They think that there are a lot of issues in memory. You have to get you got this pointer and send it out of scope, but actually the smart pointers doesn't work that way. And of course the next issue, but the powerful tools, powerful static analysis solutions are not free. You have to buy them. I will have a talk a little bit later about static analysis, so I will cover it with additional details. So, but what we have done with it? We actually did tuning for static analysis. For example, I also will cover it a little bit later, but we created two different dashboards from static analysis tools, one for developer and one for our security team, and we switch off all false positive checkers and rule sets for static analysis for developers and state only for us. And we have to perform tuning, so we analyze a lot of outputs of static analysis. We mark them by hand, which one are true positive or false positive. After that, we count the precision. It's for example, TP, it's the count of true positives, FP count of false positives, and we just count the precision metrics for that, you can see. And switch off all rules which are more than 70%, which are less than 70% have precisions. All these false positive checkers we send to developers, for example, of static analysis tools. If it was our static analysis tools, we tune them themselves. If it wasn't possible to fix the rules, sometimes we met these cases. So we just switch off them. As you can see, our tuning work was very useful. After about 15 iterations of this process, we could increase the precision from less than 20% to 70%. But we, of course, switch off a lot of interesting stuff. For example, everything which connects with use of the free stuff, we have to switch off because static analysis works awful for this. And we also actually have the problem with code coverage. For example, if you just take covariate analysis tool and run it on Google Chromium code, you will find that covariate doesn't cover the 100% of Google code. It covers only about 20 or 30% from scratch. You have also to tune it sometimes. We have a problem because we have we have our own CI, and our CI system, we install the compiler dynamically. So we have infrastructure based on virtualization, and every time we build the Chromium code and our code, the compiler installs to machine, and the covariate, for example, analyzer has issue with it. It couldn't catch all output from input and output from compiler. Well, let's go to dynamic analysis. Dynamic analysis is cool. It's very cool, actually, if you want to find, for example, memory corruption issues. It's more useful than static analysis. But you have to build, for example, it finds the memory corruption, it don't have a lot of false positives, but actually you have to create the multi-platform testing infrastructure, and your developers have to write fast tests, or you could just, for example, turn your unit test into sanity tests, as we did. Well, we have actually two directions of dynamic testing. The first is the sanity testing. It's when we just take our unit tests and build them with sanitizers. And the second is fast testing. Yeah, the sanity testing, it's really easy to perform. If you have unit tests, you just have to build them with sanitizers and run as you usually run your unit tests. It's very useful. We find several critical vulnerabilities using it, and we don't have to create any additional code. We just take our unit tests, build it, and run it. It was very nice. We use LLVM symbolizer for getting information. You know that also the LLVM now has new tool, LLVM covered. You could just use also them, and it's very useful, and you don't have to do a lot of work. But actually, you could use also fuzzing approach. We called it unit fuzz testing. It's the similar approach to Google. Google released his tool called LeapFuzzer. Maybe you heard about it. It allows you to create the special fuzz tests. It's just similar to unit tests, but in this fuzz test, you have to wrap the function or model or functionality you want to test, and Fuzzer could create the special output, the special clever input for your function. It could mutate. So, for example, if Fuzzer is based on genetics algorithms, it's analyzed the populations throughout the bad populations and use only good populations. So it's like unit testing, but the data is generated automatically by Fuzzer. It's very good. It's very nice approach, but you have to write special tests. Or you could just rewrite your unit test, but it's the work for your developers anyway. You couldn't just take the unit tests and run the LeapFuzzer on them. You also just couldn't take your old browser, for example, and run your browser on it. There is an approach for layout tests. If you develop your own browser, you know about layout tests, random layout tests. Some people try to fuzz using layout testing. It also could be useful for if you try to fuzz, for example, renderer and to find some DOM-based vulnerabilities. Maybe you heard about the one useful fuzzer from Google, also Domato, written by Ivan Frantic. So we have, for example, also several projects connected with special fuzzing like Domato or DOM-based fuzzing. We perform it because we sometimes changed our renderer. But all this stuff do the security team. Our developers are not involved. They are involved in only in unit fuzz testing. So let's go to the next step, final security review. Final security review, we call it VSR, or actually we have the special term, security audit, sec audit for us. When we have important feature, it's the big feature or it's the security feature, the architecture analysis, the static and dynamic application testings are not enough. We do additional analysis performing by our hands. We just check that all features have our requirements. Our requirements we gave at the design analysis step. We also check that all vulnerabilities which are found by fuzzing or static analysis are fixed, or maybe there are the tickets the tickets in our tracker for fixing them. We just check that there exists. Yeah, and we also sometimes do additional handmade fuzzing. For example, if we know that our password manager uses SQLite database and stores the data there, we could just write some simple fuzzer that pollutes the database and try to run our browser on the polluted database to find out some crashes or issues with it. Sometimes we perform such the handmade penetration testing for important features. But if the feature, for example, the changing design or maybe changing the text of the button, we don't do such testing for not important features. Of course, in agile development, it's very hard to use it because it could create bottlenecks. But we create automatization for this process. First of all, this process is not blocking for non-security features or for little features. Also, we have the special form. We created a lot of automatization. We have a special form when the team tries to release feature. It should provide the data about this feature, and after it, the ticket automatically creates in our project tracker. We find out that there is a new security audit candidate, and we can just dispatch to our team the tickets for load balancing of our team. So we create a lot of automatization, and sometimes if the feature is not important, or if we know what everything is fine, for example, we have the history of static analysis and dynamic analysis. We have the history about design and architecture. Sometimes it's just a checklist for security team to go to the ticket, to analyze that everything is okay, and to close the ticket. Well, let's go to the summary. Actually, for huge projects, the SDL is still complicated process, but if you work with your developers, managers, it will be very easy because you could educate them to improve their skills in security, and then after that they start to create more good products. So you have to spend less time for this process. Actually, also, if you want to perform your SDL process, you have to work with your threat models because it's very important, and you have to explain your threat models to developers, to managers. You have to explain how to fix the threats because not every developers know it. You have to create the competitions, trainings, and some stuff like that for improving your skills, improving your developer skills. Also, sometimes you could just you may have no information about the issues in your product. If so, you could start from the response stage, from the end. But so nowadays there are several options for start response stage before the SDL. For example, you can go to background or to the HackerOne, and you can run the special closed testing program. In this program, nobody could disclose the issues. Never. And you could just send your product to this program. For example, these portals could call the top of researchers to hack your product, and you could run it for 1 month or for 2 months and get the information about the issues. So if you want to grab the low-hanging fruits, you could just run the closed program before you start your SDL, and it could be useful. You could get information about the security level of your products, and that's good that no one could disclose it even after 90 days. Never. So they have the special agreement with their participants that no one could disclose the issues never. It's pretty convenient. So that's about the process. What's about the methods? Actually, there is no silver bullet. There are several good cases for finding vulnerabilities by dynamic analysis. For example, if you want to find memory corruption issues, you have to perform DAST. If you want to find out some issues in code which is not covered by DAST, dynamic analysis. You have to perform SAST, and you could just find some interesting issues. For example, you can find not memory corruptions, but some issues with unutilized variables, issues with dead code, or some stuff like that. I will cover it a little bit later. But you have to know that you should enhance and configure your tools if you want to get the best effect, because from scratch it's not good. You have to spend a lot of time to tune it and to work with the developers of such SaaS tools and to work with your developers. So that was the first part. If you want, we could make some break. The break, and then I'm ready to cover the second topic. Maybe you have any question? Yeah.
First one is, I wonder how are you managing one-day vulnerabilities of Chromium?
If I understood correctly, the question is about managing the Chromium vulnerabilities. Yeah. Well, okay. Yeah, it's quite interesting. We have special system which monitors the Chromium dashboard. For example, you even could find, if I don't have the internet access here, but if you provided me, I could show you my open source tool. You could grab it from GitHub. It uses the Google Chromium search portal, and you could just provide the bug ID to this tool, and it finds the commit. You don't have to download all source code. You could just run my Python script and get the commit of the bug even when details are closed. It's just search the bug ID in all commit messages. It's very convenient. So we perform these actions, and we check which the severity level of this vulnerability. So every time the Chrome releases his release node, we analyze all issues from list, from node, and check if it's easy to explain, or if it's easy to exploit, or if it's very dangerous feature. So we find all commits connected with vulnerability. We check the layout tests, because sometimes if you just analyze the layout test of Chromium, you can find out the idea of POC. Sometimes layout tests are just very similar to POC. Yeah, we check if these issues have the layout tests. We check the code fixes, and we analyze how easy it's to use, how easy it's vulnerabilities to use, and how it's dangerous. So if it's if it's dangerous vulnerability or it's very easy to use, we perform the backport commits to our branch, not changing the full version. So we have different Chromium versions because we couldn't use the latest every time. The latest in our Yandex browser, we have a gap between versions actually. But for security features, for security vulnerabilities, we perform the backport if we find out that there is a serious issue. It's the one thing. Actually, we have, as I mentioned before, our bug bounty program, and sometimes we get issues and vulnerabilities from Chromium. For this process, we just install the same Chromium version as our browser has, and check if it's working on our version and in Chromium. If it works both, we tell researchers that he should send his report to Google VRP, because we don't pay for Chromium code issues. But if it works only in our browser, we provide rewards.
Because of the gap, you said the version. Then maybe there are vulnerabilities from third-party libraries. And then the version is mismatched.
For third party, I have a some details for you. For third party, we created also the special system which analyze all third party components. You know that all Chromium third parties have the special Chromium README file with mentioned where you can find the version of the component and where you can find additional details. We have the system which analyzes all Chromium README files, checks the version, and try to find vulnerabilities in some vulnerability databases. There are several vulnerability databases. Some of them are open, some of them you should buy. So we create a special system. We get the information from these databases, and we have something like third-party vulnerability search for it, our own SFML project. So it covers our Chromium. When some vulnerability is found in a third party, this system creates the ticket in our tracker, actually on me. So the ticket says that something wrong with the third party, please go and check. And after it, we could go and check and update the third-party component, or maybe just switch off if it's not very popular. Sometimes it happens.
Then are you forking all of the third-party libraries?
We are working on...
Yeah, I mean, are you cloning them and managing by yourself, or...?
Yeah, of course. We have the third-party libraries. Some of them are Chromium, some of them are own. For example, we have own third party for some video codec, as far as I know, and some other stuff. For example, in our browser, we have additional enhancement for TLS, because in Russia there is the Russia cryptography cipher for government resources called GHOST. And we have the special GHOST TLS enhancement. It's the special cipher suite enhancement, and we have the special third party for that, which Chromium doesn't have. So we have to manage all third parties and work on them a lot.
Okay, thank you. And second question is, how many bug reports you got from our program?
I think that we get about 5 or 10 reports a month usually, but sometimes it's more, sometimes it's less. Depends of our process, depends of our releases. For example, sometimes we release some new functionality with special advertisement company, and after it we could get a little bit more interest from bug reports. But often it's just, I think more than 80% of them are connected with Chromium, not with our browser. So we got the bug reports, but they are connected with Chromium code. So we sometimes we even create our own patches if we know that vulnerability in Chrome is dangerous for us, for example. But it's not usually. Usually we wait for fixing from Chromium. Thank you very much. I hope I understood it correctly. Sorry for my bad English. I'm actually not native speaker.
Do you have an open source fuzzy project like OSS project?
Oh. We don't have open source products from company like OSS Fuzz or some stuff like that. Deep Fuzzer for browser, we don't have this. But for example, I am the security researcher who interested in browser field. So sometimes I create some open source tools. You can find them. Sometimes I even create the POCs from the layout test, for example. We also have the Telegram channel about the browser security. I'm the inventor of this channel in Russia. So I provide sometimes information just like in open source. It's not the product, it don't have the SLA, for example, or some stuff like that. But yeah, you could find a lot of ideas. And for example, the tool for searching the commits, you could just go and download it and try it. Okay, let's go to the next topic. It's about static application security testing. During this topic, I will cover the SAST approach in Yandex, some appropriate and false positive cases for static analysis, and also I will show our own statistics and conclusion about this process. So let's go to the SAST at Yandex. When we are talking about SAST, we are thinking about the four main static security testing steps. The first one is, of course, the analysis of code sources. So every product has source codes, and you could just perform the source code analysis for finding vulnerabilities. There are several tools for that, and it's very it's convenient and very popular way. But also, it's not enough, because your product also have configurations. For example, it's not about even browser, it's also about other stuff. You have a lot of configurations, like that Evgeny mentioned about Nginx. So we have to create additional stuff, additional programs for configuration checks, like Jixi. You could just download it and use it. We have also several similar systems in our company, which performs also configuration checks. So it's very important step, and usually you have to use some exotical stuff for that or create your own, because sometimes you have your own known issues for configurations, and it's very important to fix them. There is also the dependency inspection approach. So a lot of products have third-party components, have dependencies, and they are not connected to your code. You often could not influence to them, you could not fix them, and you don't have a time actually for that. So the dependency inspection is in our direction of the SAST. For this direction, we use, for example, the database search. It's very useful approach. You could just create your own or buy the database of vulnerabilities and try to find well-known or even not well-known issues in your third-party component, and we think that you don't have to analyze the code of your third party. You should just update or switch off if it's possible to update, for example. And the last part of our SAST approach is the secret search. It's interesting part, because this means the search of some private and secret information in source codes. For example, sometimes you can just find the OAuth token in your source code. Or sometimes, for example, if we try to speak about the infrastructure, some people could write Python scripts or Bash scripts with passwords, with some critical credentials, tokens, some information which are open to all developers, and we don't want this. We want the sensitive information, like tokens for publication for Android Play, for example. Yeah, we don't want it to be available for everyone. So we have the special technologies, the special system, which analyze the source code of product, the source code of infrastructure parts, to find out some sensitive information, like the tokens, like the credentials for publications to Play Market or Apple Store, and other sensitive informations. And if this system finds some security sensitive information, the special ticket is created, and the developer have to fix the code and have to delete the token from the source code. And also, if he don't do it, the token will be disabled in short time period. I think 3 or 5 days maybe after it, the token will be disabled, and he could get some issues with publications, for example, or in his infrastructure system. So the secret search is also the approach for security static application testing, not only analyzing the source code. It's a little bit more complicated process. So after that, you can see our system. We perform all these 4 stages and send information to our database system. And after that, some tickets are created directly. For example, if we find issue about third-party components, the tickets are created directly to developers or to security team. Just go and fix it. But sometimes we have complicated outputs. For example, the outputs from static analysis tools, and we want to create the tickets using these outputs because it could be poisoned by lots of false positives potentially. So we send this information to dashboards. Don't create the tickets. But the dashboards are available for our developers, available for our security team, and we monitor them. And if we find some interesting issues and if we find true positive cases, we just create the tickets ourselves. And yeah, and actually we have 2 different dashboards, as I mentioned before. One for security team with all checks and all controls, all procedures, we can monitor them. And one for developers with only the good precision cases and analyzers for saving their time. So why do we need SAST actually? Some cases you could just solve using only SAST. For example, the secret search or third-party analysis, it's the SAST is the most effective way to solve the issue, to solve the problem of the security of the third-party components or maybe the security of your credentials. Also, we have some platform-specific code, as I mentioned before, where the dust is not possible or the dust is not very effective, like in Linux. Yeah. Or sometimes we even don't have resources to write our own fast tests, or we have some poor covered product by unit tests. For example, sometimes we got the projects which acquired by our company, and they were developed by not by our teammates. So sometimes it's not, they don't have very good quality, and we could not write a lot of tests for them and just use the SAST approach. Yeah, and also the SAST also. The SAST also useful when you just need to perform one-time check of the product. You don't have to build infrastructure, you don't have to write additional code. You could just set up the static analyzer and run it on the project. It's very convenient. So we use several code analyzers in our SAST process. My next topic, my next slides will be connected only with source code analysis. I could not cover all steps of SAST, sorry. Well, we use several static analyzers. For C, C++, JavaScript code, we use the proprietary solution Coverity. And for C++, we also use Clang Static Analyzer. It's the open source. All that have the draw line are open source. You could just download and demo them. Coverity actually is not open source, but it's, in our point of view, it's one, the static analyzer for C++, it's only one, the static analyzer that it's possible to use, because others are very full of false positives, or maybe even complicated to integrate them to your CI system. Yeah, for Python we use the Bandit tool. It's like very simple IST search. It's very convenient. And for Java we use the find bugs and find security bugs. What we want to find using our static analysis. For web applications, we have several goals. The first is the parsing dangerous formats and serializations. So you know, for example, about the XML. If you parse the XML file in your web application unsafe way, you could just get the XXE vulnerability, and it's very easy to find such issues using SAST, because you could just find that your code use unsafe XML parser. Also, there are several insecure or platform usages. For example, in web development and Android applications, you could, for example, use the unsecure random for generating the cryptographic case or some stuff like that. So it's very easy to find these cases, because the SAST analyzers could find the insecure usage of API or even dangerous parameters, because they are well known. They are good documented, and it's okay. You also could find the SQL injections if you use the standard frameworks. So if you use the standard frameworks or DB engines, it's possible to find the SQL injections, and it will be efficient. But if you have your own ORM system, for example, forgot about it. Every specific cases are not good for SAST at all, actually. So. Yeah, of course, if you have improper escaping of your output in web application, for example, if you use, for example, React in a dangerous way without escaping, it also could be found by static analysis. For binary applications, we want to find the race conditions and memory corruptions, but I have a teaser for you. The memory corruptions is very bad. The memory corruptions is very hard to find effectively using the SAST. Okay, let's see at some examples. Here is the output of the Coverity and the issues, and you can see the example of the 0x1 vulnerability. So I don't know if I have some, oh yeah, I can explain. So it's very simple. We have int buffer size variable, yeah, with the 32 value. The value is 32. And we have the sum code. So in this condition branch, the special buffer is created using this variable buffer size constant, yeah. And after that, the sum copy performs, and we get and in code you could see the setting the value to the buffer, and you see that if I will have the length 32, I will get out of bounds, because in the buffers I have to use the indexes from 0 to 31. As you know, here we can get the index of 32 because of in this branch, and these conditions, the condition is wrong because we could get the buffer size the 32. I think it's clear, yeah. And Coverity tells that we have out of bounds right here, and it's correct. Yeah, that's okay. It's quite. The next sample is the unsafe XML parsing, and you can see the output of Bandit analyzer. So here you could see the several warnings about from this analyzer about unsafe XML parsing. I mentioned before. So you can see the first lines of code. We just import the XML U3 unsafe library to our code, and we get the message with low severity that we try to use XML. We try to parse XML data unsafe way. The XXE could happen here. But we don't run this code only. We don't use this object. We just include it to sources. But here we call it. So here you see we have the object EAT in our code, and after that we call the method parse, and we get here the message with severity level medium, because we started to parse the XML unsafe way, and in here we can get the XXE, for example, vulnerability. Actually, Bandit doesn't perform any taint analysis or some stuff like that. It could not save if the user input passes to this code, but it shows you all potential cases. Yeah, but let's go to the false positive, because the true positive are not so interesting. You can find them a lot. So, okay. The next is the false positive of Bandit. You can see that the Bandit here shows us the warning about the pickle library. But actually, the pickle library, it could be dangerous if some user input passed to it. But here is okay. We have our own internal cache, and the user input doesn't go to it. It's okay, but Bandit could not find out it, as it shows you every potentially dangerous places in code. So it's not very convenient because you get some false positive also. The next false positive is very interesting. You see it's about the JavaScript. And here we can see the Coverity, which found the DOM-based vulnerability, DOM-based cross-site scripting. Why? Because we have the variable airtail, which gets the document referrer, and after it, we use the document, we call the document write, with this this data, you know? And of course, if we don't perform any escaping, it's dangerous. And DOM-based cross-site scripting could happen. But we have our own escape realization here. So we have our own escape function. And we know about this issue, and we protect the code from XSS vulnerability. But actually, Coverity could not find out it. It doesn't understand any specific. So it tells you here you have DOM-based vulnerability, but we don't have it because of our own escape function. It could not analyze that our own escape function performs the escaping of the output here. Well, that's the false positive case we got and analyze it. Another, yeah, it's also the Coverity, but it's about the shared unique pointers I mentioned before. You could see we use partner DKInfo, and it's the unique pointer. Yeah. Here. It's a unique pointer. So it's the smart pointer, yeah, and when we just send the get, we don't get the out of scope because smart pointers have different reference counting, and the object will not destroy it if the reference still exists. So it's the smart pointers works the same way. So we don't have the vulnerability here, but Coverity actually don't understand, Coverity actually doesn't understand the smart pointer semantics, I'm sorry, and we got the false positive here. So we need to analyze it and to fix. Let's go to some statistics and summary. So if we see at our month, it's about the month statistics. If we see about the statistics of vulnerabilities, we found several using the Coverity. We found a few with Bandit and the small amount of fine sick bugs. Actually, we switched off all low-level alerts. We see only at high severity vulnerabilities and medium severity vulnerabilities. So we have only these statistics here. Actually, about the 30 issues we got in a month. you could see. If we see at the true positive, false positive rate, so you can find the statistics here. You could see that Coverity gets the more true positive samples because of our tuning also. We work a lot of, we switch off false positive checkers, we get in touch in command of the Coverity, and so it's the result of the complicated work. And also we tune the find-seek bugs, the bandits, switch off checkers, but sometimes we get the false positive even after this work. So what's our point of view? The SAST is good enough for dangerous format parsing. When you try to parse dangerous formats like, for example, XML or even YAML in Python, you know, it's about the serialization, or using pickle, or some standard dangerous formats, the SAST is good enough to find your issues. Not ideal, because you will still get some false positives, but it's good enough. You can find about 70% of precisions for these methods. It's also useful for finding SQL injections for standard frameworks and standard cases, not in your own ORM systems, because it's because the SAST couldn't understand your own type casting or prepared statement stuff. So don't try to to find out issues in your ORMs. It will be horrible for you. Well, and of course, for C++ code, the SAST is good enough for initialized variables and fields for classes. Yeah, if you want to find these types of issues, the SAST is good enough. Average precisions we got at encoding and escaping cases. If you have the standard frameworks, for example, React, Angular, JavaScript, some stuff like that, you could use SAST with average precision, but it's still sometimes like coin. It's not very good, but still. And the awful precision you will see at memory corruptions of C++ applications. It's awful. Use the dynamic testing for that. Don't try to use SAST, because if you have C++ code, you got a lot of false positives, and it will be very, very difficult to tune, unfortunately. Yeah, and what's about the implementation? Analyze only relevant code. So if you try to use some static analyzers, first of all, switch off your test branches for testing, switch off third parties, because you don't want to find vulnerabilities in your tests or in third-party code. It's useless for you. So analyze only appropriate code, appropriate branches. Also, tune checking rules, because a lot of rules in standard static analyzer engine are false positive. You should switch off, find out which one for your code, and switch off them. It's the difficult part of implementation, actually. Unfortunately, if you want to use it in big products, like, for example, our Yandex browser, 10 gigabytes code, 10 gigabytes of code, you have to do a lot of tuning for SAST analysis. Yeah, we also recommend to divide the analysis output in two parts, one for developers and one for your security team, because if your developers see a lot of false positive, they will be very upset. They want to they want to work with your security team, and that's not funny, actually. So we create a special division, and for us it works. Yeah, it's very, very useful. And also work with your developers, get feedback from them, work together to improve the analysis, because of sometimes it's very complicated for security team to find out how some part of code works, because the code could be very complicated, could be full of templates or third-party stuff, or some difficult cases. So we recommend to connect your developers to this process. Maybe you should create the security champions or some stuff like that for helping you to improve the static analysis. Yeah, and also don't give the mess to your developers. Don't create tickets with false positives. Try to filter every bad stuff, because your developers, it's very useful resource, and you should use it very effectively. The general conclusions about the SAST. Yeah, some SAST checkers are good, but we think that today is one of the most important things in static analysis is the taint analysis. Have you ever heard about taint analysis? I think yes. The taint analysis is the way to find which user input sends to the some potentially dangerous parts of code. So it's about the analyze of user inputs and about the analyze the dangerous parts of code. If user input sends to the potentially dangerous parts of code, it's very, very bad. Yeah, and nowadays not a lot of static analyzers perform such analysis, taint analysis. And even if they perform, they do it, unfortunately, not very good. Because you saw the examples already, you have seen them. And sometimes the taint analysis could help you to understand that there is okay with that code because there is no user input which sends to this dangerous part of code. But actually, there is an issue. And even the expensive solutions like Coverity actually are not good in taint analysis yet, unfortunately. Maybe they will increase the quality. Yeah, and for memory corruptions, use sanity testing and fuzzing. The SAST is very horrible for that cases. Well, that's it. Thank you for your attention. Sorry for language. If you have any questions, I would like to answer. Feel free to contact me if you have questions after the talk. You could just send me a mail or find me at Telegram. You also could find me at Twitter or in GitHub. I can provide some. Sometimes I drop useful stuff, especially for browsers. So thank you very much for attention.